otherwise I ramble. All right. So, introduction to sequences. Some of this will seem familiar. I mean, it's patterns of numbers in a sense, and things that you have done to write equations before, but we're not really taking it through an algebraic writing equations type of direction here. So, your definition of a sequence. It is a set of numbers in a particular order or pattern. Each number is a term. Okay? So it's a set of numbers in a particular order or pattern, and each number is a term, and we have term numbers that go along with this as well. We have finite and infinite sequences. You know what infinite is. Finite's the opposite of that. Infinite goes on forever, finite does not. So the definition of a finite sequence is a sequence with a limited, oh, I can spell right, limited number of terms. Okay. So our example could be 2, 4, 6, 8, oh, something like that. Okay. Infinite would be a sequence with an unlimited number of terms. So this one may look like 2, 4, 6, 8, ... and then we would just know the pattern to go on and continue and make it go on forever. So definitions and notation are going to be a big thing today. So your first term in the sequence is denoted by a sub 1. Then each subsequent term is denoted as a sub n plus 1, where n plus 1 is the term number in the sequence. So if we look at this example here, a sub 1, that's the first term, that's going to be 2. Right, so if we number the terms, this is 1, 2, 3, 4, 5. So that 1, 2, 3, 4, 5, those are our n numbers. So a sub 5 is going to be 14. To get a sub 8 and a sub 14, I have to continue my pattern here. So what's happening here to each of these numbers? We're adding 3. So if I have 14, then that would give me 17, then 20, then 23, 26, 29, 32, 35. I don't know how many I need, so let's see. So I need 8, so this is 5, 6, 7, 8 is 23. So then 9, 10, 11, 12, I need 2 more. So it'd be 38 and 41. So a sub 14 would be 41. Depending on the pattern, depending on the type of equation you have, maybe you have to list them all out to get to what you need, but not always. Depends on what kind of formula you're expected to have and what situation you're in. But let's talk about some more definitions first. Any questions on that so far? All looks good. So, since each term value is paired with exactly one term number, a sequence is a function with the following properties. The domain is the set of term numbers so my term numbers are 1, 2, 3, 4, 5. The range is the set of term values. It's your outputs. So your input and your output, just like it has been. In an infinite set, the domain is the set of natural numbers. Your natural numbers are your positive integers. They're your counting numbers. 1, 2, 3, 4, 5, and so on to infinity. Doesn't include 0 or the negative numbers. So it's the first term, the second term, the only thing that would make sense. Okay? So unlike a lot of functions that we have where your domain can be lots of different things, your domain is always the natural numbers, always the whole numbers there. Okay? Then we have two different types of formulas we can write. We can write recursive formulas and explicit formulas. So we're going to talk about recursive formulas first. No, they're your counting numbers. All right, so recursive is a rule in which one or more previous terms are used to generate the next term. Okay, so like when you say I'm adding 4 to the previous term or whatever is happening. So we're going to look at the Fibonacci sequence. If you don't know what that is, when I said that this morning, I was like, you know what, we should probably, the Fibonacci sequence is pretty interesting, but we're not going to talk about it today. I'm just going to give you what it is. So it's 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so forth. So it says, in this sequence, a sub 1 is 0, a sub 2 is 1, and then for each term after that, how do you think I get each term? What's happening here? Yeah, you're adding the two previous numbers. Now, it gives you these two, because it works here, like, there's not two numbers to add together to get that one, right? That's why they have to give you the first two, because it kind of doesn't really work right there. But then after that, you add the two previous numbers, right? So once they give me this and this, then I can say, all right, well, that means that a sub n is equal to, when I want to say I'm adding the two previous numbers, the previous number before that would be a sub n minus 1, and then the one before that would be a sub n minus 2. So I take the term before it and the term before that, add them together. And this only works when n is greater than or equal to 3, because they gave me 1 and 2, so it doesn't work for those, but it works if I have 3 or more. And that's what a recursive formula looks like. So in order for me to find the 78th term, I have to know the 76th and the 77th term, which would mean I'd have to write it all out. That's the way the recursive formulas work. Okay, so looking at that, it says give the first 5 terms of each sequence. So if I want the first 5 terms, this is 1, 2, 3, 4, 5. There's my 5 terms. So I know that the first term, they gave me a sub 1, it's 25. So I'm supposed to take, for the second term, I'm supposed to take the first term and subtract 7, gives me 18. Then I subtract 7 again and get 11. Then I subtract 7 again and get 4. Then I subtract 7 again and get negative 3. Does that make sense? That's called a recursive formula. It's one where you'd have to kind of write everything out if you need something past that. We're going to skip number 2. I have too many examples on here. We don't need them all. All right, so this tells us to write a recursive formula, then find a sub 8. So we're supposed to write the formula. So I know at the very least I have to give the first term. I might have to give more than that, but at least I have to give the first one. Then I can look at this, and each time I'm doing what here? Adding 4. And so since I can just, hey, start from the beginning and start adding 4, then that means my a sub n would be a sub n minus 1, so the term before it, plus 4. And since I gave the first term, that only works when n is greater than or equal to 2. There is my recursive formula. Then I have to find a sub 8. All right, well, I have 1, 2, 3, 4, 5, so I need 6, 7, 8. So I'm adding, what do we say, adding 4. So this is 29, then 33, then 37. It's 37. So if I give you the first term, it's not going to work when n is 1 because there's nothing before it. So since I gave you the first term, this is only going to work for the next term on. For the Fibonacci, I gave you 1 and 2, so it only works for the third term on. It's past whatever you're given. Does that make sense? That's a good question. Anything else? All right. Let's see if we can come up with a pattern here. So I know I have to at least give the first term. A sub 1 equals 1. Okay, so then I'm going to, here I add 2, then I add 5, then I add, 14? So that doesn't seem to do much for me, right? So maybe we think Fibonacci-wise, and I add the 2 terms. Well, 1 plus 3 is 4. 3 plus 8 is 11. Would that work? So if I add 3 plus 1 is 4, I double it and get 8. 3 plus 8 is 11, I double it and I get 22. That makes sense? Add these together, get 30, double it and get 60. So that looks pretty good, right? Which means in order for me to do this, I have to have 2 terms in there. So I have to give you not only the first one, but I have to give you the second one. A sub 2 has to equal 3. That way I can say that the nth term is 2 times the 2 previous terms before it added together. So that would be a sub n minus 1 plus a sub n minus 2. So you take the 2 previous terms, add them together, and double it. Since I gave you terms 1 and, or you gave, or whatever, since the formula gives terms 1 and 2, this is only going to work, oops, not a, when n is greater than or equal to 3. Oops, I don't know. Oh my gosh, I'm telling you, my brain and my hand are still not agreeing today. Okay, everybody okay with that? Mm-hmm. Yeah, it's because it's the domain part. All right, so then I need a sub 8, so that's 5, so I need 6, 7, 8. So I'm going to add 60 and 22, that gives me 82, multiplied by 2, I get 164. I'm going to add 60 and 164, that's going to give me 224. Double that, I'm going to get 448. Stop me if I'm wrong, because I'm doing this in my head. So then when I add these two, that'll give me 612. I double that, and I'm going to get 1224. 1224. What questions do you have? Okay, so those are recursive formulas where you have to have the terms before it. Let's look at explicit formulas. So this is a rule in which the nth term is defined as a function of n. Okay? This is more the actually writing the equation type of stuff that we're kind of used to. So this says give the first 5 terms of each sequence. So when I have my first 5 terms, 1, 2, 3, 4, 5, this is 1, 2, 3, 4, 5. These are the term numbers. So these are my n's. N equals 1, n equals 2. So when I substitute them in there, 1 times 5 is 5 plus 1 is 6. 2 times 5 is 10, makes that 11. 3 times 5 is 15, makes that 16. That would make that 21. That would make that 26. Easy enough? So that's my explicit formula, because then I could just substitute in the term number. If I wanted to talk about this recursively, what am I doing to each term here? What am I adding? Adding 5, okay? So I could write it as a recursive formula that way. All right, we good with that? I don't think we need to do number 6. So now we're going to write the explicit rule and then find a sub 25. So if I want to add one, that means I have to think about it in terms of n. So these are my term numbers, 1, 2, 3, 4, 5. And if I look at so I'm adding 3, then I'm adding 5, then I'm adding 7, then I'm adding 9, like I'm not adding anything constant there. But how could I relate my term numbers to the actual term values? They're just being multiplied by themselves, or they're being squared, right? So I'm squaring the term number, so my a sub n would be n squared. It's the term number squared. And then I'm supposed to find, so that's that. Then I'm supposed to find a sub 25. That means that would be 25 squared. What's 25 squared? 625. Thank you. That is one we should know. There are my two answers there. Okay. We good? So let's look at number 8. So my term numbers are 1, 2, 3, 4, 5. And this time I am adding 2 each time. Right? That constant that you're adding tells you that you have to multiply your term number by something, by that number basically. So I'm going to have to double my term number and then do something to it. So if I think about it that way, what would I be doing here? If I double this one, so 2 times 1 is 2, then I add what? 7 to get to 9. If I multiply this by 2, I get 4, then I add 7. Double this and add 7, and so forth and so on, right? So your a sub n is going to be 2 times n plus 7. That's what that 2 tells you. So that's that part. Then I have to find a sub 25. Well, that's going to be 2 times 25 plus 7. So a sub 25 is 57. Okay. We good so far? Okay, so now we have these two sequences, and we want to write a recursive and an explicit rule for each. The recursive is usually a little easier to write, so we'll write that one first because that can help us. So here, what am I adding here each time? 3. I'm adding 3 each time. So that means that I really only have to give, for my recursive, I have to give the first term. That's 4. Then a sub n is going to be the term before it, so that's a sub n minus 1, and I'm just adding 3. And since I gave the first term, then n has to be greater than or equal to 2. There's my formulas. Okay, so that's adding 3 tells me I'm going to have to triple my term number. So a sub n is going to be 3 times n, and then what? Yeah, your term numbers, this is 1, 2, 3, 4, 5. So 3 times 1 is 3, and then I add 1. 3 times 2 is 6, and then I add 1. Right? So I just have to add 1 here. And that's my answer. So you look at number 10 and write the recursive rule for that. What are we adding each time? 1/2. So this is a sub n minus 1 plus 1/2, where n is greater than or equal to 2. So since I'm adding that 1/2, that tells me that a sub n equals 1/2 times n, and then I have to figure out if I have to do anything else to that. Do I have to add or subtract anything after I do 1/2 n? Nope. And it might help to write out your term numbers, because even though they're simple, it's easy to kind of get mixed up in your mind which numbers are relating to each other. So if this is n, 1/2 times n, that just totally works. That's my answer. Okay. What questions do you have? Okay, so that's super basic sequences. We're going to talk about specific sequences now. So if you'll get that other set, we have arithmetic and geometric sequences that we're going to look at. Today we're just looking at arithmetic. And, ooh, goodness gracious. All right, so an arithmetic sequence is a sequence in which the difference, okay, difference is an important part of this, between, I'm just abbreviating between, any two consecutive terms, consecutive is one right after another, oh, I can spell it right, consecutive terms is constant. The ones where we're just adding 3 every time, or adding 4, or adding a half, or whatever, that makes it an arithmetic sequence. Right? That common difference is the numerical difference between any two terms. And the variable is d. So d stands for difference. That's our common difference. If we're adding 3 every time, then your common difference is 3. It's that easy. So when we look at these instructions, it says determine the common difference, and then it says then find the next 4 terms. We're not going to do that because you're totally capable of that. And I know you're capable of figuring out the common difference as well, but I just need to at least point something out here. So if we look at this, between these two, I'm adding 8, right? Between these two, I'm adding 8, and I'm adding 8. That means D is 8. Bless you. You see how easy that is? So then here, I'm subtracting 3, subtracting 3, subtracting 3. So I'm adding a negative 3. Okay, that negative is important. So this means my common difference is a negative 3. Don't lose sight of the negative. Okay, you can't think that I'm adding the difference or I'm subtracting the difference. Always think about it, it's adding. So you're either adding a positive number or adding a negative number. That way you don't get your signs messed up. Okay, we good with that? All right, so I'm going to give you a rule for this instead of you having to try to determine, and am I doubling it? Am I subtracting 2? What am I doing here? Here's your arithmetic sequence formula. So the nth term of any arithmetic sequence can be found using this. A sub n equals the difference times n minus 1 plus a sub 1. That's it. A sub 1 is the first term. We already know that. And d is the common difference. So we're going to use that to write our rules like it tells us to. So it says write a rule for each sequence, then find the indicated term. So what I need to write this is I need the common difference. So the common difference here, what am I doing? Adding 6, right? I'm adding 6 each time, so the d is 6. The first term is 7. That's pretty easy to figure out, right? So then a sub n is equal to the common difference, which is 6, times n minus 1 plus 7. There's your rule in terms of n. You don't even have to distribute or anything. That's it. And just a little side note here. It's been a while since I looked at this because I made this assignment probably over a week ago. But I usually look in and see how Delta Math does it too, because every now and then they show you some different things, and sometimes I don't know why the heck they're showing you certain ways. But anyway, I don't recall, it seems like in the back of my mind, and I could be wrong, that like if you looked at the example for one of this problem or how they worked it out, that they actually distribute all that, which is fine. There's nothing wrong with that, but it'll take either answer, because as long as the value's the same, it's fine. So you might as well stop. I mean, that's an AP part of it, right? You learn to just stop when you can stop so you don't make some ridiculous mistake by distributing or something. So you're done there. But we need to find a sub 32. So that means that that's going to give me 6 times 32 minus 1 plus 7. So that's 6 times 31 plus 7. So 6 times 30 is 180. 6 times 1 is 6. So I get 186 plus 7. So a sub 32 is 193. What questions do you have? All right, so you go ahead and do number 6. Find D, a sub 1, write your equation, and then we want a sub 24. I got negative 249. Any questions? Are we all good? Awesome. Okay, so let's look at finding some other stuff. So it says to find the indicated value. So to find this value, the first thing I'm going to do every time is to write out a little equation. So I know that I'm going to use a sub n equals d times n minus 1 plus a sub 1. I'm going to do that first every time with whatever information that I have. So a sub n would be equal to, they gave me d, that's 7, times n minus 1 plus a sub 1, which is 29. So they basically gave me everything I needed. So I write my little equation, even though they didn't ask me for that. Then I want a sub 36. So that's 7 times 36 minus 1 plus 29. That's going to give me 7 times 35 plus 29. So 7 times 30 is 210. 7 times 5 is 35. So that gives me 245 plus 29. So 245 plus 20 is 265, plus another 9 is going to be 274. Okay. What questions do we have? We good? All right, we're going to skip number 10. Let's look at 11. So the first thing I'm going to do is write my little equation. A sub n equals, they didn't give me d, I don't know d, and then n minus 1 plus a sub 1, which is 11. So I have 2 unknowns now instead of just 1 in there, but they did tell me a sub 25. So a sub 25 equals 107, so that's like a sub n. That's equal to d times, well, n is 25, so it's going to be 25 minus 1 plus 11. So now I can solve for d. I get 107 equals d times 24 plus 11. Can totally do that. Subtract 11 from both sides, we get 96 equals 24d. So what does d equal? 4. Because you're almost at 125, right? Let me try that. Okay, easy enough? write it down, substitute in everything you know, find what you need. All right, let's look at 13. It says if a sub n equals negative 76, we have a sub 1 and d, so let's write our little formula. A sub n equals d, which is negative 5, times n minus 1 plus negative 21. Okay. I could have made that minus 21, but I'd already put my plus sign, so it really doesn't matter either way. So I'm actually looking for n. I can find that because they gave me a sub n. That's negative 76, so I'm going to substitute it in right here. Negative 76 equals negative 5 times n minus 1 minus 21. Do I have to distribute to solve this? No. I can, but I'm not going to because that's more work and more places for me to make a stupid mistake. So here I'm going to add 21 to both sides, so that's going to give me negative 55. That's equal to negative 5 times n minus 1. Now I'm going to divide both sides by negative 5. That'll give me 11 equals n minus 1. So n equals what? 12. Basic algebra. I mean, it's all that is. So you just have to know what your formula is so that you can go and do those magic algebra stuff that you're so good at. So now we're going to do, we did this at the end of that first page of notes. We're doing it again, but this time we have a rule. And we understand now that our common difference, that's why we were doubling that in there. It says to write an explicit and recursive formula for each sequence. All right, so let's see what's happening here. What am I doing each time? Adding 2. I'm adding 2 each time. So my recursive formula can do a sub 1 equals negative 19. So that means that's a sub n minus, a sub n equals a sub n minus 1 plus 2, and then n has to be greater than or equal to 2. So then my explicit formula, a sub n, that's equal to d. Well, d is 2 times n minus 1 plus the first term. So that's minus 19 or plus a negative 19. It doesn't matter either way. We good with that? What questions you got? All right. You do number 16. Find the recursive and then find, oh, I don't care what order you do it in. I'd do the recursive first, but that's just me. When you're done, check yourself with me. Let me know if you have any questions. Your assignment is in Delta Math.